Hi everyone. In this video we're going to be going over the concepts of an increasing function, a decreasing, and also critical points of a function. So you probably learned to read from left to right if you learned to read in English. So whenever we say the words increasing and decreasing, what we're talking about is what are the output values of a function doing as we read from left to right. So as an example, think for a moment and tell me, what do you think about this red function? Do you think this red function is increasing or decreasing? Well, as we're going from left to right, the output values of this function are actually increasing. So, in this case, we're talking about an increasing function here in red. Now tell me what you think about this blue function. Do you think that this curve represents a function that's increasing or decreasing? And this is actually a trick question because for this curve, we can actually identify, an interval or two over which you might say this function is increasing from left to right. And we also see an interval there sandwiched in between where this function is actually decreasing. So you can have functions that are both increasing some places and decreasing some places. So what I want to point out next is this critical points idea. So the title of these notes are increasing, decreasing, and critical points. Right here, in this area, whenever my function has just been decreasing over some interval, and it's about to be increasing over some interval, this, right here, where it's neither increasing nor decreasing, this is called a critical point. Critical points are places where your function is neither increasing nor decreasing. So this little blue curve represents a function that has two critical points. Okay, so here's some definitions here. A function is increasing if the derivative is positive. Okay, so remember, the derivative sort of represents the steepness of a function. And so where you have a positive derivative, or you might say the f prime evaluated at that point, if it's greater than 0, that means it's positive. If your derivative is positive, that means your function must be increasing. It's talking about some sort of positive steepness to your curve at that point. And likewise, if your derivative turns out to be negative or less than 0, then we say it's decreasing. So anytime you see a curve that looks like this, and it decreases from left to right, what we're saying is the sort of steepness to this curve has a negative value. So it has a negative derivative. Now, we say that a function is strictly increasing if the function only ever increases and never decreases. And likewise, we say it's strictly decreasing if it only ever decreases and never increases. Now, I'm going to scroll up again to show you our first curve, our red curve. This was our first example, and we said that this appears to be an increasing function. In red, well, that function in red was this one. This is the red curve from before. And if I take the derivative, well, it's going to require, the derivative quotient rule, and in taking the derivative, that -2 doesn't matter, but that's not the point of this lesson. You can go back and look at derivative quotient rule if you want to see how we got from this one to this one. But my point is that if we look at the derivative, we expect that it's going to be positive, at least where we saw, because we said the function was going to be an increasing function. And sure enough, in the denominator, where you see this to the 2 power happening in the denominator, that means the denominator has to be positive, right? Because even if you have a negative number and we square it, we end up with a positive number. So at least as we're doing calculus with real numbers, that square in the denominator means the denominator has to be positive. Now the numerator could still be negative, right? So in looking at my numerator right here, I have positive 8 times an exponential function. Well, it turns out that the exponential function has only positive values, right? If you're not familiar with that, I really encourage you to try graphing the exponential function on Desmos. But the way that this looks, if you graph an exponential on Desmos, is it passes through the point 0, 1, and then it goes up. And on the left, it actually approaches the point, approaches the horizontal asymptote at y equals 0. But you can never have a 0 value for your exponential function. You can never have a negative value with just the plain old exponential function. So the numerator is positive as well. And so that means this derivative must always be positive. And if this derivative is always positive, that means this red function is strictly increasing, right? So it's increasing everywhere if the derivative is positive everywhere. Okay, and then now let's recall the blue curve. And I'd already marked it all up, but this nice blue curve goes up and then down and then back up again. Remembering the blue curve, it had 2 critical points there. And now I present to you this new definition for critical points. So a point is a critical point if the derivative of the function is 0, right? So if it's neither increasing nor decreasing, that means the derivative has to be 0. Now this is the function that actually generated that blue curve, the one that we saw on the previous page. And if I take the derivative of this function, just the power rule gives us x squared minus 1. And if we want to find those critical points, we have to set the derivative equal to 0, right? This is the idea. I find the derivative first, I set the derivative equal to 0. This gives me an equation that I can solve for x. It turns out that this particular equation has 2 solutions, x equals -1 and x equals +1. So these are the 2 critical points. And let's go back up and look at that blue curve and just verify that you see my critical points are appearing at this being x equals 1, the critical point. And then of course over here, this critical point is at x equals -1. So you can find the location of your critical points by taking the derivative and then setting the derivative equal to 0. That should give you, one equation that you can solve for your one unknown value. Okay, now just to summarize what we've learned in this video, the function is increasing when the derivative is greater than 0, or you'd say the derivative is positive. The function is decreasing when your derivative is negative. And also, if the derivative happens to be continuous, if the derivative of your function is itself a continuous function, then that derivative must pass through a point where the derivative is equal to 0, whenever it changes from positive to negative. Right, and so whenever your function goes from increasing to decreasing or decreasing to increasing, it's necessary, if your function has a continuous derivative, then it's necessary for your function to pass through a critical point as it changes direction. Okay, well, thank you guys, and I'll see you in the next one.